Thank you, Paul. As Paul said, I'm the Keynote Chair, Nikhil Balram, CEO of Mojo Vision, and I'm here to introduce the keynote speakers. Before I do that, I want to speak briefly about the philosophy behind putting together the keynotes. Some people think we just collect all the names of great candidates we can come up with, put them on a giant poster board, put a blindfold on John, and have him throw 3 darts. I want you to know this is not true. We don't use a blindfold. Of course, I'm joking. So here's the real process. We choose one speaker from the display industry to tell us about some interesting new technology or product directions from within the industry. This year, the topic is micro-LED, subject near and dear to my heart. The other 2 keynotes ideally come from outside the industry to bring us a vision of big things that we should care about. And there is no question that the biggest of big things that is happening today is AI. AI has been with us for a long time and even gone through a few up and down cycles. But the last 2 years have been an incredible rocket ship, just powering upwards. AI is truly eating the world. So today we have 2 very distinguished speakers offering their unique perspectives on AI to challenge and help us think deeply about what the display industry can do to benefit from this huge transformation. So our first speaker is Aparna Chennapragada, who's Chief Product Officer for Experiences and Devices at Microsoft, where she's leading efforts to transform the world of work with AI. She has 25 plus years of experience as a technologist, product builder, founder, and chief executive, successfully leading companies and organizations through massive platform shifts from the internet to mobile to AI at Microsoft and previously at Google, where I had the great pleasure of working with her, at Robinhood and Akamai. Aparna was the visionary founder of Google Lens, an AI product with billions of monthly queries. She serves on the board of eBay and was previously on the board of Capital One. She was recently selected as one of Fortune's most powerful rising executives in America. She has a master's degree in management and engineering from MIT, a master's degree in computer science from UT Austin, and a bachelor's degree in computer science from IIT Madras. Please join me in welcoming Aparna. The floor is yours. Thanks, Aparna.
Good morning, everybody. Welcome to Display Week. I'm Aparna, as Nikhil, and he bravely pronounced my last name too, which is great. I'm here to talk about, in the next few minutes, I'm going to share my thoughts and my observations about the evolution of AI, and in particular, the evolution of intelligent interfaces. And it's evolving as we speak. In fact, I was joking with Nikhil backstage that as this keynote happens, there may be a new model getting dropped. So we'll see about that. I want to share my observations in 3 parts: the past, the present, and the future of AI. But first, I want to tell you a small story. I grew up in South India, and one of my most formative memories growing up was watching and helping my father, who was a doctor by profession, but really a sculptor and artist by choice. And so this lesson that seeing is understanding is something that I felt I internalized firsthand. And visual expression and visual understanding is core to what makes us all human. And I know I'm preaching to the choir here, given the room here, but I just wanted to start with sharing that. And it's no surprise that I've always been drawn to rich and expressive interfaces through my work. One of my first projects when I started at Google 17 years ago or so was this idea that you should be able to search what you see. So I was a bright-eyed, bushy-tailed engineer and product manager working on this product called Google Goggles. And the idea was powerful, that, hey, you should be able to use the camera to detect what's in the picture and be able to give information about it. But here was the problem. This was before large language models, for sure. This was before deep learning. This was even before LSTMs. So this was back in the day when engineers would do painstaking feature engineering, draw bounding boxes around parts of images, do segmentation the old manual way. And of course, when it worked for books, it didn't work for places. When it worked for specific products, it didn't work in a general way. And on top of it, this was, you're uploading data over 3G, so median like 6 seconds or so. One of the lessons I learned was that the only thing worse than being slow is being slow and wrong. So you waited for some time and then you got the wrong answer. The idea was powerful. We were too early. And in tech, being early is the same as being wrong. Fast forward a few years, I want to share another experience of building an AI product. As these smartphones were starting to take off, I believed that these smartphones should be smarter. They should be able to proactively give you information, assist you. And today, assistant is a word that a lot of us use, but back then, again, it was a novel idea to say, how can the computer do more work on your behalf and not just wait for you to ask questions, but proactively give you highly personalized and relevant information. So I worked on this product called Google Now, and the idea again was to say, can you give rich visual pieces of information, like, for example, hey, it takes 30 minutes to come to the San Jose Convention Center, you better start now. Or here's an obscure but really deep article on the web for this specific niche interest of yours, or your flight is getting delayed, etc. What was magical about the product was the promise of the interface. In fact, we won the Best Innovation Award in Popular Science that year. But it did not reach what I call Google scale, right? Hundreds of millions of users or a billion users. And I think, again, the insight here was the interface was rich. The intelligence under the hood didn't support it. So that's my first observation. In AI products, we'd have to have the interface be really proportional to the intelligence. If you look at where these two products were in the timeline of AI breakthroughs, particularly if you look at image search and so on, this was the pre-deep learning CNNs really outscaling the feature engineering moment. And so the intelligence under the hood could not support a very broad, promising search what you see or proactively give you any information kind of an experience. Another example is speech recognition. Again, assistive interfaces were built, demos were built, but what makes the translation from a good demo to a great scaled product is, in this case, for example, the word error rate dropping below the human recognition, human accuracy. And then it becomes a product, and you see that in the usage charts. I then went on to shape core parts of Google Search. And here, I think the gears were falling in place, right? On one hand, you had PCs or later phones, the hardware being ubiquitous and everybody being able to access information. On the second, you had ranking algorithms that just the flywheel of ranking algorithms with the usage data started spinning. And then on the third, the consumer shift itself, the learning curve for typing into a search box turns out to be practically zero, right? And so all these three factors came in, and we launched many products and experiences. So armed with these lessons, I did not give up on my original vision, no pun intended, of being able to have people search what they see. So I founded this product called Google Lens a few years ago. I was still obsessed with this idea of letting machines see what we see. But this time, three things came together, right? So number one, the hardware sensors. So given the scale and the supply chain and the kind of the S-curve on the mobile phone side, both on the GPUs to process images, but also camera sensors, the hardware started lining up in terms of being able to process a whole bunch of information, add a rich sense of metadata to the photos and so on. The second thing that started happening is, of course, the step function in AI with deep learning, with CNNs, and the data that feeds into these models. But most importantly, the third thing, which is often gets lost in building consumer products, is the shift in consumer behavior. Phones were everywhere, and storage on photos was practically free from major providers. And so what that meant was that people started taking pictures not just of sunsets and selfies, but of shopping, products, and street signs. And so suddenly you had this confluence of all three things come together. So the product that I founded went from 0 to billions of searches per month in a span of 4 years. So this leads me to my next observation, which is successful products in general, but specifically in AI that I've seen, are often at the intersection of intelligence. There's a step function in intelligence. We've got to look for that. If that doesn't change, you make great demos, but the products don't scale. Second, supporting hardware, either at the data center level or on the edge or both. And then the third being this consumer behavior shift. What used to be novel and specific to a small set of people, how is that becoming more and more mainstream? So that was the last decade in AI. A lot of interface innovation, deep learning, but in some sense, the intelligence fell short of interface. So where are we now? And I would say, without being hyperbolic, we are entering the golden age of intelligence by a few different dimensions. And of course, this is like post-transformer, post-large language models, post-reasoning models. There's a whole bunch of model improvements. This chart here shows, this is a leaderboard based on rating from experts in different fields. And this is the LM-SIS arena. And it shows, again, like the steady climb of almost all of the top models from left to right, up to beyond 1,300 plus scores. And the scale of these models is astonishingly huge, too. So we went from pretty fast from tens of billions of parameters to hundreds of billions of parameters to the top models have trillions of parameters here, right? Which is a proxy for how capable the models are getting. The bottom line here is that we are entering a phase where the intelligence is ahead of the interface. We have an overhang here that is yet untapped. At the same time, the other good thing that's lining up here is that the cost of intelligence is dramatically going down. Now, on the training side, yes, because of just the natural way that the GPU cycles are working, and the cloud infrastructure. But I think even on the inference side. So this chart shows, for example, the cost of inference for 1,000 tokens going from 0.024 to 0.00085. So a 280 factor drop in inference costs from 2022 to 2025. Right. What I'm saying is the models are getting bigger, smarter, and cheaper. Right. Not only that, the capabilities of these models are also changing, right? So it is not just that the instruction following and the next token predictor, a part of the core large language models is getting better, that we are adding more capabilities. They're getting more multimodal. We have real-time voice that's starting to work. And my favorite, this is the deep reasoning part of it, right? Where instead of just thinking about the model being able to predict the next token and answer questions effectively, whether you think ChatGPT, Copilot, Gemini, they're all kind of products that are built on the idea that you can answer questions. You prompt and you get a response. But deep reasoning allows for thinking longer, thinking slower, breaking down complex hierarchical problems, doing step-by-step verification, and simulate more of that complex thinking that happens when humans do, which is relevant for a lot of knowledge tasks. So this chart actually shows that many of, again, the reasoning models or the hybrid ones, right, Claude or OpenAI models, do start to show kind of significant improvement in these agentic reasoning tasks. So this brings me to my next observation. Clearly, we're in the opposite side of the problem where there's a lot of it, there's an abundance of intelligence. And now, when I want to look at where the product or the interface here, right? As it happens with every technology shift, the first wave of products that get built are incremental. I call it the just add AI phase, right? And by the way, this is not specific to AI. I remember, back when the web had started and I was working in Akamai, the first content delivery system, the first websites were really scanned PDFs, like PDFs of brochures, right? Because it's kind of an analog to what existed before. Fast forward to mobile, the first mobile websites were, desktop sites shrunk to the form factor of mobile. So we're seeing something similar here, which is, hey, chat layer on top of a model, a wraparound model, works. So let's make sure that we can add that functionality. So all the existing players and startups, Microsoft included, Microsoft, Adobe, Google, we've all kind of said, hey, what happens if we add features that bring AI to our products, whether it's search, creativity, or productivity, right? So that's what you see here. Clearly incremental, but even so, useful, right? With reasoning models, you start to say, well, actually, we can do a bit better, not just faster answers. This is Microsoft Copilot. Let me see if I can play this. So what it's doing is saying, hey, like for questions or for tasks that need a longer answer or a deeper insight, how can you kind of take the time, tap into a reasoning model, give a much more deeper answer here or deeper response here? So the just add AI phase works. It's incrementally useful. But there's an opportunity cost in the sense that there's a much bigger opportunity to rethink products and processes entirely AI first. I want to show you one example here is a startup, and there are many companies that are now starting to do this, and if you haven't heard the word agents, then you're clearly in a blessed circle somewhere. Everybody talks about them, but the idea really is to say, can we rethink business processes, productivity workflows, but just even tasks that we all do to process information and get work done, as instead of us doing it, can AI do that? And to me, the definition of agents is can we have independent processes that can not only just like answer questions, but take tasks assigned that can be delegated and break that down and to kind of go seek those goals. This is an example of a startup that said, what happens if we can reimagine an AI software engineer agent, right? Notice again that this is not just a feature that you can add AI to it. It's basically saying, hey, the agent has its own shell, its own file system, it has its own workspace, and you talk to it just like you do with a coworker in Slack or in Teams, and you say, hey, can you go get that done? And I've used a few of these products, and we are building, obviously, agents for software with GitHub. And there is a clear step function in terms of how much these agents can do as the models get better. So our observation here is that there are going to be many of these agents that can start to take broader and bigger and more complex tasks. And as the models get better, and as the feedback loop with the humans get better, the agents will get better. We'll start narrow, but we'll go broader. And still, if you see, fundamentally, we're still in this textual interface. I call it the DOS era of AI UIs. We're still in this command line. I mean, don't get me wrong. I grew up on Linux. I grew up on Unix. I love my Unix command lines and so on. But with AI products, if we're thinking about putting this in the hands of billions of people, non-expert users, you've got to have an interface that doesn't require people to know the magic incantations and the prompting spells and, I don't know, the 600-page, it's like man pages, Unix man pages for 2025. So we've got to be able to have a better and more intuitive interface. And we're starting to see some of these early green shoots here happen, right? The DOS to GUI transition is starting to happen. Here are a couple of screenshots I have of Copilot saying, hey, if you're browsing a website, can you see what I see? Like I'm looking at places to stay. I don't have to text and explicitly, if you think about your assistant, you're not going to just text. You're going to point to things. They're going to see what you see. And so can we start to have that modalities work for you? Up above is Gemini and ChatGPT, where real-time voice works. And what's interesting here is that the interface also starting to change the interaction and the product experience. So it's not just about putting a layer of voice. Anecdotally, what we see, and even in data, what we see is that once you add voice, once you add a camera and vision, the nature of interaction for the users also changes. They have longer conversations, for example. They're able to give much more richer pieces of information. In fact, a good example is my 86-year-old mother, who is a retired medical professional, and I've taught her to use voice because it's much easier for her versus pecking at the keyboard and being able to use AI chat products. This, again, going beyond voice and just images, this is an example of how some folks are taking it even further. World Labs, which is Dr. Fei Fei Li's startup, is starting to say, how can you take a prompt or a 2D image and generate an entire 3D scene, right? So get a semantic output versus a flat 2D set of pixels. So for example, on the left-hand side is the input image. And are you able to get a much richer 3D scene generated from it? And so it starts to point to possibilities of more immersive interfaces that are generative, right? Again, we're at the beginning of kind of going from the DOS to GUI era, but I see very promising signs here. So what's next? So we've seen kind of this era of, hey, there's an interface that overshot intelligence. And I think in the last few years, there's a huge step function post-LLMs in terms of this, what I call the abundance of intelligence and waiting to be tapped into. And what happens next has to start with the question, well, what is the AI assistant that we all have, and what is the AI assistant we deserve? The AI assistant we have waits for you to ask questions in bits and pieces and responds to your prompts. And of course, it's getting more and more helpful, as we just saw. The reasoning helps, the UI and the experience helps, the speed helps. It is starting to not just search, but to synthesize and solve and answer questions, but also start to kind of do things like browse the web for you, and with some of these model improvements and so on. But by and large, it is a prompt response, answer question kind of an interaction that I have with the assistant. My vision is that to be truly helpful, your AI assistant needs to go much further. It needs to see what you see. It needs to hear what you hear and what you speak. It needs to say and show, particularly for this audience, you'll appreciate it, and show what you need in a much more richer, intuitive way, and then get things done for you. If that is the ultimate vision, we need a few things in place. So this leads me to my next observation, which is we will need truly multimodal I/O, not a grafted on, hey, let's add image recognition, or let's add voice models and so on. But this end-to-end, thinking about pixels plus voice plus vision plus gaze plus touch plus, and all the input modalities, almost like a sensor fusion budget, right? And all of these thought of as a stream of tokens that need to go into the model. And of course, when you type or text, that's still kind of like a major piece of input. But how do you kind of combine all of these input sources into a stream of tokens that get fed into the model so that you can get a much more richer experience? And of course, all of these things have to be done under, give or take, I don't know, a few hundred milliseconds, right? And that's the other thing. Speed does matter, and interactivity, when it comes to interactive and natural interfaces where you want humans to be able to interact with these things much more naturally and not have to adapt to AI tools versus the tools adapting to humans, you do need that speed constraint. So there are a lot of technical leaps that will need to happen. The other thing that we will need to fall in place for this ambient AI assistant is we will want fully generative UI. What do I mean by that? So one of the key unlocks here for models is that ultimately, if you think about large language models, They're excellent at large amounts of text. They've been trained on trillions of tokens of text. And code turns out to be this amazing special case structured language that has copious amounts of training data on the web. So these models are really damn good at code generation. And at the end of the day, everything is code. UI generated is code, image generated is code, and so on. So one of the key unlocks in terms of capabilities for these models is the ability to generate code. So if these models can generate code, they can generate UIs personalized to you, personalized to your context at this moment, at this time. So my mother can get her, large print, simple selection menu, and I can get the Swiss Army knife, power user mode for the same task, like say trip planning and so on. So generative UIs and dynamic UIs have to be part of the equation here. My final observation, as I think about kind of where AI goes next, is, Mark Andreessen said famously, software is going to eat the world. And I'd say the model is eating the software. And it's happening across multiple industries, multiple types of tasks, multiple types of products. And this is one to pause and stare and think, well, how does it apply to my area, my field, my team, and my industry, right? Here you see a couple of examples, right? So one pretty simple, this is Claude, one of the AI chat products. And again, because it can generate React code or Python, et cetera, it can create pretty much interactive visualizations based on the data on the fly, right? You didn't have to program anything. And below is one of the many no-code platforms that take you from a prompt to a fully deployed app in a few minutes. And so in this world, when model is eating software, you'd have to think about, hey, what are the ways that first of all, that loop continues, where the model, if the model is eating the product, what are the durable differentiators that your product has? But also the other way around, which is what kinds of interactions with the user, how can the product feed the model back to make that a proprietary advantage for your area, for your product, and so on. So those are my observations and thoughts in the last several minutes. I hope I've been able to share some of my excitement and experience building AI products the last decade and this decade. And I want to leave you with a few thoughts, food for thought, as I thought about, hey, how does the world of AI intersect with the world of display? So food for thought number one, as I talked about this intelligent assistant that can see what you see and show what you need, does an intelligent assistant need an intelligent display, right? How can the display become more dynamic and more of a learning and a model forward one, and learn what to render using AI models? Food for thought number two, as we think about displays as not just static endpoints, but these dynamic decision engines, do we have the right models, and do we have the right silicon and compute to be able to go farther in this direction? Obviously, there are early signs of this. So you do see on-device multimodal LLMs and VLMs. Llama Vision 3 is a good example, where you see on the Ray-Ban glasses, there is really some progress in terms of fewer than 7 billion parameters. Again, there's severe constraints, especially when you think about that form factor, but taking displays at large too, and figuring out, hey, what kinds of models do you need? And can you do with the general purpose models, or do you need like a focused, specific, task-specific set of models? The same thing holds for the compute as well. So you have, Qualcomm has the Snapdragon with like 40, 60 TOPS class of neural cores. But is that enough? Again, as you think about this loop between the model, the raster, the panel, and the user feedback, instead of thinking about a linear, how do you start to think about it in a loop? And then the final food for thought for you all, as you think about this way more than probably any other group in the world, what is the role of pixels? Are pixels really evolving to become tokens to train the model for an intelligent display, right? I mean, think about it, like, do you have an overall token budget where you say brightness, resolution, latency, all of the characteristics of displays are really going into one single token budget? And you can kind of say, okay, make dynamic trade-offs based on, again, where the user need is and user interaction is, based on, for example, the gaze of the user. You say, okay, I can kind of do foveated rendering and like kind of take the hit in terms of like the broader pixel quality versus the focused quality and so on. So the broad question here is, if we stop thinking of pixels as kind of these endpoints and start to think about these as interchangeably with tokens that feed into the model, but also that are generated by a model, how does it change the nature of intelligent display? So we began my talk by saying, seeing is understanding, a lesson that I learned by watching my father sculpting and painting. And we are talking about this ambient AI assistant that can see what you see and show what you need. So I hope I've been able to share with you all my excitement and my experience building these AI products. And my core optimism is this, right? I'm a self-confessed AI optimist, and I do believe that while humans have judgment and taste and humanity, there are many, many ways that AI can actually connect the dots, process large amounts of data, and bring insights. But the other part of the equation is, how do you render these insights where they matter, right? It could be a 65-inch hologram, it could be a windshield heads-up display, or it could be a micro LED lens. But the intelligent AI needs an intelligent display, and I hope you all are inventing it. Thank you.